Now let's talk about space curves, also known as vector-valued functions. This is a helix that's created actually from a circle in a sense. Let's recall what a circle is. So here's a circle, x squared plus y squared is a squared. Let's recall what a circle is in parametrized. If I make the radius larger, circle, if I make a larger, the circle gets bigger, of course. And if you notice, this here, this is x equals a cosine t, y equals a sine t. This here is a parametric version of this equation here for a circle. All right, so if they're overlaid one on top of the other, if I get rid of this one by clicking on the blue, then the green is there instead. And so if I click on the blue instead, so these are the same thing because a cosine t quantity squared plus a sine t quantity squared, if I put those in here, I get a squared out of that. So this is the parametric version of this equation. All right, now if I add a z to that, here it is right here. If I add a z value, let me take out the t first. Let's take out the t, and I'll show you that this is the equation that you saw in the previous, it's the exact same thing, basically. Previous Desmos 2D, basically. You can do the same thing here. Now, once I add a t in here at the very end of my z component, it's t, then what it does is for every t value, it pulls it up. And there we go. So if you look, when that t is when you're looking down along the z-axis, you still got the helix. But now, if you consider this one here, like let's say you want to look down the x-axis, let's say the y-axis, then you have a sine curve. So when y is 0 here, or for slices, let's just say y is 0, you have x is a cosine t, z is t, and so you get a cosine graph out of this. When I look down the x-axis instead, I get a similar sine curve, actually an actual sine curve, a sine t, t. And if you look at, I go over here and I look at t, a sine t, that is your sine curve, okay? Sine curve. So if it's t, a sine t, that's your sine curve. It's t, a cosine t, it's your cosine curve. All right, and the way that I've made this animate is by putting b here for pi, b times pi, and I'm changing the value of b. And then, of course, if you wanted to go to the other side, you would put a value here as well. Okay, so that's that. So if you consider that different viewpoints of this helix, sometimes you get a sine curve or a cosine curve, and sometimes you get a circle out of this.